Today's topic is right hand thumb rule. It states that if you wrap around your right hand around a straight current carrying conductor in such a way that your thumb is pointing towards the direction of the electric current, then your fingers will wrap around in the direction of the magnetic field lines of the magnetic field. So let us say there is a current carrying conductor in which current is flowing in upwards direction. Then according to the right hand thumb rule, your thumb will point towards the direction of the electric current that is in upward direction. Then your finger will wrap around in the direction of the magnetic field lines of the magnetic field. Similarly, in the second case, the current is flowing in downwards direction, so your thumb will point in downwards direction. Then the magnetic field line will flow like this. As you can see, the magnetic field lines are flows like this. So, and here the magnetic field lines are flowing like this. Is Fleming's left hand rule. It says that if you stretch your thumb, your forefinger and your middle finger in such a way that they are mutually perpendicular to each other and your forefinger is pointing towards the direction of the magnetic field and the middle finger is pointing towards the direction of the electric current, then your thumb will point towards the direction of the motion, that is magnetic force. So let us take an example. Here you observe that the magnetic field is flowing in this direction and the current is flowing in this direction. So according to Fleming's left hand rule, you may arrange your fingers accordingly. We observe that the direction of the current is opposite. So you not need to fold your hand in various direction. You only observe that the which is opposite direction. If one is opposite direction out of two, then the force also be opposite. So here the direction of the force is inward. So in second part you observe that both the direction of the magnetic field and current are opposite. So the force acting on it is same as in normal, that is outwards. Now here the direction is totally different, that is the direction of the magnetic field is in inward direction. So according to Fleming's left hand rule, if we put our fingers accordingly, then we observe that the direction of the current is opposite. So the force acting will also be opposite, that is in the left side.
Fleming's left hand rule. Fleming's left hand rule states that when you keep the thumb, index finger, and middle finger of the left hand right angles to each other, the middle finger shows the direction of current, index finger shows the direction of magnetic field, and then the thumb will show the direction of motion. As you can see in this figure, the thumb, the index finger, and the middle finger are at right angles to each other. The thumb shows the direction of force that facilitates the motion. Magnetic field is shown by the index finger, and the middle finger tells the direction of current. Before coming to the questions, I would like to tell you two cases which we need to understand before doing the numericals. The first one says that if the direction of current or magnetic field doesn't match with the tip of the respective fingers, then the direction of force will be opposite. It means that if you struggle to put your fingers at correct direction of current or magnetic field, then you can simply place the tip of your finger at right angles to each other at the plane of paper, and then you can check if the tip of your fingers are opposite to current or magnetic field. The direction of force will be opposite to the one shown by your thumb. The second condition says that if the direction of current as well as magnetic field is opposite to the tip of your fingers, then the direction of force will be the same when they were matching. Now coming to the first question, here we can see that the direction of current is opposite to my tip of finger and the direction of magnetic field is same as my tip of my finger. But here you can see that my thumb points at the direction towards the camera. But now I will consider the force to be inwards. Why? Because the current is being opposite to my tip of finger. Being the simplest case, here I can see the direction of magnetic field and current are same as my tip of finger. So I can say that the force is pointing outwards the paper. According to this rule, if we hold the current carrying wire in our right hand so that the thumb points in the direction of current, the direction in which our fingers encircle the wire will give the direction of magnetic field lines around the wire.